All right, kind of a tricky problem, and certainly I'm not sure level of the detail your teachers are expecting you to go through. It sure is nice to have access to a computer to realize that although this is a positive term series, I want to point out that I did move forward in it. So it started at 1 off to infinity. I kind of moved up to 13 to infinity, and there's a point to that. And the point to that is, I want something that compares nicely to something that I know about, but it didn't compare nicely to numbers that were below 13. Like, for example, I wanted to make sure that this was going to work out for a number, and I arrived at number 13. And someone says, how do you do that? I'm looking at this over here, and I'm realizing that this might compare nicely to 1 over 2 to the n, which I know is 1 over 2 to the n, which I'm going to say convergent geometric series. But the deal about this one over here is that you wondered, is this really true? Like, is it really true? And then you got to start thinking about it. And the bottom line is it's not easy, but it's nice to have a machine to help you out with it. But you're getting this over here. I'll write this down for you. And I'm wondering, is this below this one over here? And this, I'll be honest, a little bit of struggle for me. And I wrote it down, and write this one, it's going to be n squared times 2 to the n less than, well, then you get 2 to the n plus 3 to the n. That's not so bad, right? Then I'm going to kind of move things around a little bit, and I can say 2 to the n, and then I get n squared minus 1 less than 3 to the n. And I'll be honest with you, I had to play around with it. And someone says, what do you mean you're playing around with it? I'm wondering when that inequality holds. Now, certainly I know 3 to the n overpowers the left side at some point, but I had to play around with it. Now, you can play it safe by saying, just at 1,000 it's going to be true. But I played around, and certainly you could try 1, and what do you get there? You get 2 times 0, and that would certainly be less than 3. That worked out pretty well. Right now, you could try, that 1 worked out. Let's try 2. So what do you get? You get 4. And then what do you get over there? You get 4 minus 1, which is 3. And then what do you get on the inside? You get, let's see, that doesn't work there, does it? Because 3 squared is 9. So then you start to realize that there's, this thing kind of like bouncing around a little bit. And I'm going to say, I kind of kept working on it, and I arrived at the number 12, all right, for n greater than or equal to 12. And so what I do is I started up. That's all I did, started it up. So what I do, I make a comparison test now. So the comparison I'm making is between these two over here, n equals, let's see, I'm going to start at 13 now. Again, you could start at a much larger number if you wanted to. Play it safe, like 1,000 or something, really doesn't much matter. N squared, and that's going to be 2 to n plus 3 to the n, is going to be less than or equal to this guy over here, term-wise anyway, 1 over 2 to the n. What about this over here? This definitely converges to a number. So if this converges, what about this one? It's also convergent, all right? What's the big struggle over there? Getting the numbers. You may be curious how I did this over here. I used a machine to do it. You don't have to do that, by the way. Thank you.